I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. In 1997, I read an essay that did something unusual. It did not teach me anything new. It explained what I had already been doing for 3 years without knowing the name for it. Long, the essay was Eric's S. Raymond's, the Cathedral and the Bazaar. I was Technical Services Manager at ICONZ, New Zealand's first commercial internet service provider, managing the Security Operations Center, the Network Operations Center, product development, and a team of 15. And in the middle of all of that, I read an essay that reframed my entire professional life. I'm Andreas Hamberger. This is the Hamberger Report, where I cover the untold history of the operating system that runs the world. This is episode 2 of the History of Linux series. Today we go from 1994 to 1998, the years when a hobbyist kernel became the infrastructure of the modern web. The years when chaos became architecture. Raymond described 2 models for software development. The Cathedral, source code developed in secret by a small exclusive team, released at long intervals, carefully controlled. The Bazaar, source code developed in public, released early and often, with contributors worldwide collaborating in what looked like organized chaos. He argued that Linux was a bazaar, and that the bazaar was winning. I had been living in the bazaar since 1994, building HTML sites iteratively, releasing work to clients as soon as it functioned, incorporating feedback immediately. I had no name for this approach. I was simply doing what worked. Raymond gave me the language. By 1999, my colleague Alan Rowath and I would build a system called TARDIS, using exactly these principles. But first we need to understand what Raymond was arguing against. The Cathedral model dominated software development in the early 1990s. Microsoft developed Windows behind closed doors. Apple developed macOS in secret. Even the Free Software Foundation's GNU project followed Cathedral principles, a small group of core developers working on components for years before releasing them. The advantages seemed obvious: careful design, consistent architecture, coordinated quality assurance. The software looked polished when it shipped. But the disadvantages were serious. Slow iteration meant bugs survived for months. Limited testing environments meant assumptions went unchallenged. And proprietary vendors added the worst dimension of all. You could not see the source code. You could not modify it. You could not legally reverse engineer it to understand how it worked. If the software did not meet your needs, your options were grim. Purchase expensive add-ons. Hire consultants to work around limitations. Abandon your investment and switch platforms entirely. This was the world I had escaped when I erased OS2 from my 486 in 1994 and installed Slackware Linux instead. I did not escape for ideological reasons. I escaped because OS2 cost money and did not do what I needed. Linux was free, configurable, and improving faster than any proprietary system I had used. I had no language for what I was experiencing. I just knew the Cathedral was slow, expensive and opaque, and the Bazaar was fast, free and transparent. Raymond's contribution was to explain why the Bazaar worked, not just to describe it. Linus Torvalds released Linux version 0.01 in September 1991. It barely functioned. It could not run a shell without crashing. We released it anyway. Version 0.02 followed quickly, then 0.03. Developers worldwide downloaded the source, found bugs, submitted patches, added features. Torvalds reviewed contributions, integrated the best ones, and released new versions constantly. By Cathedral standards, this was madness. How do you build a robust operating system by letting anyone contribute? How do you maintain architectural coherence when hundreds of developers are simultaneously modifying different subsystems? Raymond identified the key principle. He called it Linus's law. Given enough eyeballs, all bugs are shallow. In a Cathedral, A small team tests the software in limited environments. Bugs hide in edge cases the developers never encountered. In a Bazaar, thousands of users run the software on diverse hardware. Under workloads the original developers never imagined. Bugs surface immediately, motivated users debug them and submit patches. The software improves faster than any Cathedral could achieve. Raymond had 4 core arguments: release early, release often, tight feedback loops, catch bugs quickly. Linus's law: distributed testing is more effective than centralized quality assurance. Treat users as co-developers. They find bugs faster than anyone on the payroll. And the maintainer's role is to curate contributions intelligently, not generate all the innovation. These principles extended far beyond Linux. They described a new mode of production applicable to any collaborative endeavor requiring rapid iteration, including building web infrastructure for New Zealand's first commercial internet service provider. Between 1994 and 1996, I built websites in Europe. Simple HTML sites, coded in EMAS, delivered to clients in Innsbruck. My brother-in-law worked for the local Chamber of Commerce and connected me with businesses establishing a web presence. One of them was Südtirol, Heute, a local daily news program. My process was iterative. Build a basic site, show it to the client, incorporate feedback, release an updated version. Sometimes the iteration cycle was days, sometimes hours. The faster I released, the faster I learned what clients actually needed versus what they thought they wanted. This was release early, release often before I had the phrase. I was not consciously rejecting the Cathedral model. I was simply doing what worked. The web moved too quickly for long development cycles. Clients needed functional sites now. Perfection was the enemy of deployment. When I moved to Aotearoa at the end of 1996 and joined ICONZ in 1997, this approach scaled. ICONZ was building infrastructure for a country that was just beginning to understand what the internet meant. We could not afford lengthy planning cycles. We needed systems that worked today so we could improve them tomorrow. The Bazaar was not a philosophy for us. It was a survival strategy. S.u.S.E on my desktop. Debian on our most critical server. Red Hat across the enterprise fleet. 3 distributions, each chosen for what it did best. And that choice leads us to TARDIS. In 1999, Alan Rowarth and I built TARDIS, the Technical Administrative Real-Time Distributed Information System. TARDIS was a self-service portal for internet service provider customers. Users could log in, change passwords, purchase services, view billing information, and manage their accounts without calling our support desk. This sounds unremarkable in 2026. In 1999, it was revolutionary. Our competitors required customers to phone a service desk during business hours. Want to change your password? Call support, verify your identity. Wait while an operator updated the database. Want to purchase additional email accounts? Call sales, negotiate pricing, wait for provisioning. TARDIS eliminated the queue. The technology stack was pure LAMP, Linux, Apache, MySQL, and PHP for the web interface, with Perl scripts transforming customer inputs into configuration files, Red Hat for most servers, Debian for the WebNZ server, which was New Zealand's #1 hosting platform at the time. Rebuilt TARDIS iteratively. The first version handled password changes, the second added service purchases, the third integrated billing. Each release went into production immediately, serving real customers, surfacing real bugs, driving real improvements. We were not planning for perfection. We were releasing early, releasing often, and letting users tell us what mattered. This was the Bazaar model applied to commercial infrastructure. And TARDIS proved something important. Open source software could not just power hobbyist projects. It could run a country's web hosting platform. The Cathedral had no answer to this. Distributions solved the real problem. Linux was just a kernel. A functioning system needed the kernel plus GNU tools. The X Windows system, device drivers, and bootloaders. Assembling them manually, kept Linux in specialist hands only. S.u.S.E. in 1992 packaged Linux into a coherent installable system. Slackware in 1993 brought it to a wider audience. Debian that same year, with dependency management that allowed incremental upgrades without reinstalling. Red Hat in 1994 focused on commercial deployment. The distributions did not fragment Linux, they democratized it. Raymond's essay was published in 1997. The following year, Netscape open-sourced its browser code, creating Mozilla. Netscape executives cited the Cathedral and the Bazaar as the justification. The Bazaar was no longer a hobbyist curiosity. It was a viable business strategy. Today, the same pattern is playing out in artificial intelligence. OpenAI, Anthropic, and Google train massive models behind closed doors. You can use them, but you cannot inspect, modify, or own them. The Cathedral again. The Bazaar is emerging anyway. DeepSeek, Mistral, Llama, open-weight models. Research teams worldwide fine-tuning, evaluating, exposing inefficiencies. DeepSeek proved that high-quality AI could be trained at a fraction of the assumed cost. Linus's law, applied to AI, given enough eyeballs, all inefficiencies are shallow. The Cathedral promises control. The Bazaar delivers results. It won in operating systems. It won on web servers. I believe it will win in AI too. If you enjoyed this, subscribe to the Hamberger Report, new videos every day. And share your story in the comments. Which Linux distribution was your first? We chose the Bazaar. The world runs on that choice. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.